Okay, so let's talk about ependymomas. Ependymomas are derived, as the name suggests, from ependyma cells. Ependyma cells are the cells that line the ventricles of the brain, and they are usually the role of the ependyma cells is to make the CSF flow. There are specialized cells in the choroid plexus of the ventricle that can create the CSF, but the ependyma cells they line the ventricles of the brain and the spinal cord, the spinal canal, and there is also ependyma cell there. This is the reason why those cells derive or arise in those areas near the ventricles, in the ventricles, and in the spinal canal. So as you can see here, for example, there is a tumor in around the area of the brainstem, around the fourth ventricle, that usually is isodense without gadolinium, but when there is gadolinium, those tumors can heterogeneously enhance. This is not the best sequence, but as you can see, it enhances heterogeneously. Some of it is a little bit hyper intense, some of it is more hypo intense. It's quite heterogeneous, but without gadolinium it won't enhance. It will be iso-intense. And let's go back. You can see that it may be also in the spinal cord. It's more common to find in the spinal cord in adults. In children, it usually more commonly in the posterior fossa, as we saw right over here. In adults, it's more commonly in the spinal cord, and it also may be in adults in the supratentorium, like right over here. So it should enhance, but it may be heterogeneously because of cystic, necrotic area, calcification, hemorrhage. There is also something that is usual for ependymoma and help differentiate it from medulloblastoma, which is called the toothpaste or plastic tumor, which squeeze near the fourth ventricle throughout the foramina of Magendie or Luschka to the basal cisterns around it, which medulloblastoma doesn't. And this was about ependymomas.